Okay, well, welcome. Welcome to our Irrigation Basics class today. I'm David Rice with Weber Basin Water Conservancy District, and we've got Janice Terry with us today as well. She's kind of behind the scenes doing the technical recording. She'll be answering questions along the way, although if there's some questions that she runs into, she may just be hollering those questions to me. You may not hear them, and I'll repeat those questions back, and we'll just try to answer your questions along the way. So before we get started, though, I did want to say we're at the room today. Behind me, you can kind of see some parts and pieces set up. The intent of this class today is really to give you a very good overview, very good basic understanding of your sprinkler system and how you can manage and maintain your system so that effectively you're delivering water effectively to your landscape. I'll talk about lots of different parts, the component parts, different methods, drip irrigation, some different things. Many of you have taken local scapes and you're interested in the conversion of how do you change something from one to another without major work or hiring a contractor and all kinds of money. So I hope to be able to get into that as well. But I did want to also say, if you haven't been out to the Learning Garden recently, the garden's open. You're welcome to come and walk around the site. Our new building's now done. The landscape is mostly in. There's some tidying and things to do still, so don't be too critical of us. But it's a work in progress. It's coming along great. The garden should give you a lot of ideas for your landscape. So with that, let's get started. What I wanted to do first is start talking about pipe. We'll kind of just talk about the pieces. We'll do some piping, we'll talk about valves, and we'll go through different pieces of the sprinkler system. And then I'll get into what's behind me of how you lay all these parts out. And oh yes, thanks Janice. Recording this webinar. So if there's something you missed or we didn't get to a question or something you want to go back and review, you're welcome to go back. We'll have a link on our website of the recording. I don't have any slides today, so there's not going to be any PDF files or anything like that of slides. It's simply going to be the recorded presentation, and of course you can go back and reference that. So hopefully this will give you a good understanding. Again, Janice will be shooting some questions along the way as you have those. But if you have the questions, don't click the raise your hand button or anything like that. Just use the Q&A button on the bottom and just type in your question. It's not nearly as effective as an in-person class, but that's the method we have that creates less chaos and background noise for everybody else participating. So we'll do that and we'll answer those for everybody. We'll get started. So I want to start with piping. And so I'm gonna step out of the picture and then I'm gonna step back into the picture and show you things along the way here. I'll try to get as close as possible so you can see. Typical residential sprinkler systems are PVC, like I've got here, 2 different sizes. I'll talk about that in a second, or a poly pipe. Now, let's talk PVC for just a second. PVC is rigid. It's a great material for sprinkler systems. In my hand, I'm holding a 3/4 inch and a 1 inch pipe. You can see the size difference. Now, some of you might be thinking, well, what size do I use? Think of the size in volume. You will deliver more water through a larger pipe than a smaller pipe, but don't think you need to go to 2 or 3 or 4 inch. Large commercial properties where you're delivering a lot of water would go that size. On a residential landscape, you will not 1 inch connection unless you have a very, very large lot, a couple acres or something, and the service line coming into your property is larger than 1 inch, then you would go with larger. Most of you would have a service line coming in of 1 inch, so use a 1 inch pipe. You can go down to 3/4 just fine on some lateral lines. I'll talk about what lateral lines are. But PVC is a great material. It is rigid though. So with curves and different things you may run into, this has some limitations, but it's reliable, durable. If you use PVC, there are 2 types. There's a Schedule 40 and a Schedule 80. That indicates the thickness of the wall. For our climate, because of our freeze and thaw cycles, you always want to use Schedule 40 PVC. It's thicker. So this thickness of this wall. A Schedule 80 is actually a very thin-walled pipe. It's used in warm climates. They've used that in Arizona, Southern California, Nevada, some of those places. They don't have to worry about the freeze and thaw that we have. So use a Schedule 40 PVC. If you want to use a poly pipe, some advantages to poly is it's flexible. You know, this is a black poly. There's some different colors out there. They sell, you know, blue, and there's some others. There's a couple different kinds of poly as well. So if you're using poly, be aware of what you're buying as well. Now notice, I'm putting this up here, so hopefully you can see the thickness of the wall as well on this. One is thicker than the other. So for your main supply line, you would use the thicker walled poly, just the same as a thicker PVC. For drip irrigation and others where you're punching in emitters and different things, called poly irrigation tube. So the main supply lines use a thicker, I don't know what the numbers are for the poly pipe, but if you go to a sprinkler supply store, look for the thicker walled poly pipe for your main sprinkler lines. Now the advantages of this, again, it's flexible. If there is a little bit of water in there and it freezes, there is a little give to this pipe, so during a freeze. However, if it's full of water, it can break and split just like PVC. You can split these lines wide open with a pipe that freezes solid, and that ice expands and it'll break the pipes open. Anyway, that should give you a little basic understanding of poly. Now, one thing I didn't mention, with a poly pipe, and this one's not going to come out really well, usually there's barb fittings and you would have a clamp. Now, I didn't bring any clamps, but here's an example. So the barb fittings come, you can have threaded parts, the little barb fitting like this, it slides on, and then you have a little hose clamp that you would clamp around the pipe to make sure that's secure, that the pressure, nothing pushes that barb fitting off. Now in drip irrigation and in applications of low pressure, you may get away with not having a clamp, but I still would recommend putting a clamp just because you don't want that popping off. Water just goes everywhere, makes a giant mess, and doesn't deliver water where you need it to your plants. So barb fittings for drip irrigation. For PVC, you would use a PVC glue and primer, and it glues it together, and basically that's a solvent, and it's basically incorrectly, that forms a very good bond that'll last for years. All right, so with that, just really quick on pipe. I want to talk really quick about a couple methods if you have broken pipes. So in the event that you end up with a broken pipe, broken PVC, and you need to repair it, when PVC is in the ground, it's not easy to get a little coupler on that PVC and try to glue it back together. There's not enough give in it unless you dig a big long trench. It's really hard sometimes to fix that pipe. So there are products like this. This is actually called a slip fix, where these have a little rubber gasket inside. I should have had this undone. So it has a little rubber gasket. So you simply slide one end on, you put the rubber gasket on here like this, and then you're doing that on the other, and then you can actually slide this down the length of the pipe, and you do that on the other side, and then this actually slides a little bit so you can get it situated right where the break is. You cut out just a tiny little section of pipe, situate that as such, and then these tighten up, and as they tighten down on that rubber gasket in there, and it seals that fix. So those are a good way to fix a broken PVC pipe without trying to dig a lot of trench and fight to get a coupler in that joint. Another way to do this, I'll just flip this around this way, is this little guy here, and I don't know what this is technically called. It's like a little slide coupler. Now these are glued, they're glued fittings, so it glues on one end, but then this, oops, there, got it pulled out. This is able to slide in and out. So you're cutting your pipe about the right length, so this basically drops in and you can move it in, and then this isn't too far from the other one, and then you're able to slide that, you put the glue on here, tight. And so that's a glued fitting, and then this part does tighten down with, it slips a little bit and it tightens down with pliers with the rubber seal right there. So that's another way to fix a broken PVC pipe. So just a couple methods while we were on pipe I wanted to talk about. All right, so I think with that,
Can I use a poly pipe and digit and then on a regular system,
So there was a question about using poly pipe and emitters on a rainbird system. I'm not quite sure exactly what you're asking. If you're about adding emitters with sprinklers, the answer is no. Never mix drip emitters with spray sprinklers. The volume outputs are so different. You shouldn't do that. Now, if that's not what was being asked about mixing or putting drip irrigation on a rainbird system, type in a follow-up question. We'll get to that again. I'm going to talk about drip in just a minute, and we'll get into all the drip parts and make sure everyone understands how to properly use drip and spray and how the two might be able to coordinate together. So before we move on to these other components, I want to talk about valve assemblies. So if you understand the pipe, now, let me back up 1 second, because there is one important thing we talk about. So with flow, okay, we talked about the size of the pipe, the diameter. So that diameter pipe. So typically for a 3/4 inch pipe, this will deliver 11 gallons per minute through that pipe. So now, assuming that you have, that's kind of on a low pressure situation. On average pressure, it'll deliver about 23 gallons per minute. That's 3/4 pipe. Now, a 1-inch pipe with low pressure will deliver about 16 gallons per minute. And then on average pressure, about 37 gallons per minute. And that's really, really important because your sprinkler heads have a gallon per minute output. So if you know that you can deliver 16 to 37 gallons per minute through the pipe, you'll know then how many sprinklers that pipe will be able to support. If each sprinkler needs a 3 gallon per minute output, then, you know, and actually some of them are higher than that. But let's say you have, you know, let's just use 3 as an example. The sprinklers have a 3 gallon per minute output. So with just 4 sprinklers on the line, that's going to be 12 gallons per minute. If you add another 4, now you're up to 24 gallons per minute. So that's 8. And you start getting more and more. So you can't, what I'm basically saying is you need to know the flow rate so you know how many sprinklers to put on, so you don't overdo the number of sprinklers and end up not having those operate as they should with the right pressure. So there's some charts online too if you need those kind of numbers, the flow rate per size of pipe. But just some numbers you might remember. 1-inch pipe, average flow, about 35, 37 gallons per minute. 3/4 inch pipe, average pressure, 23, right around that 23 gallons per minute mark, okay? You can test your gallon per minute flow rate if you have a hose bib. You can simply take a 5-gallon bucket, turn it on full blast, and then time, how long does it take to fill that bucket? And then from that, you know 5 gallons was there, how much time was applied. You can kind of calculate out how much water goes through a thing in a minute. Do that math, that calculation, you know, based on how much time it took to fill 5 gallons. Okay, and if you need a little help with that, you know, like I said, there's some little formulas online, or you can send us some emails or something. We'll try to help you there. All right, so back to the next thing I was getting to. So now I want to talk just a little bit about valves. Okay. This happens to be a valve assembly and a filter combined, but this is the valve. And I should have had one out just separate by itself. But the valve, notice the wires, okay? The valve is what, if you have an automated sprinkler system, this valve is what's going to allow your timer to tell this irrigation zone, this unit here, to either open or close. There's a little rubber diaphragm inside of here. The electrical signal, the impulse comes in, and it either allows this diaphragm to open or close. It pushes up or down, and that either lets water flow or shuts water off. So occasionally, if you have a valve that sticks open, you know, trying to get it closed, it won't close. That means there's probably something going on inside here with the diaphragm. Now notice there's screws on top of here. Most of these valves, most companies have a way to open up that valve and clean it. Sometimes a little debris, tiny little bit of rock or something's in there keeping that diaphragm from shutting all the way, so your zone keeps running. The other issue is sometimes those rubber diaphragms simply wear out over time. They can get cracks in them. You can have a crack, the seal doesn't form right, so your valves won't open and close correctly. Rather than buy new valves, sometimes you can just buy the new diaphragm inside there and replace that and put it back together. Now, the other problem that can go wrong is this top part here, which is the wired part. And almost all the manufacturers have these, they unscrew. This is called the solenoid. This is, you can't do much with this. If it goes bad, you just replace the whole part. But it can go back on. You'd simply disconnect the wires from your irrigation wire that goes back to your timer. And you can replace the solenoid very easily so that you're not buying and having to disassemble the entire valve assembly just because this part went bad or because you have a diaphragm problem here with not opening or closing correctly. Now there's lots of different valves. There's commercial grade valves that are wired to different 2-wire connections. We're not gonna get into that. This is your typical valve with 2 wires. Notice they're both black, so it doesn't really matter. When you're connecting these, I'll talk about the connections for these in just a minute when we start talking about the whole infrastructure system, how to set all this up. But it doesn't matter which wire goes to the white common wire or which wire goes back to the colored wire that goes back to your timer. They're the same essentially, so it doesn't matter which one you use. Sometimes there's little flow control knobs that you can crank them down or up to allow a little more flow through the valve, but not always. Some of them have a manual turn on, so if you wanted to manually turn this on, you simply turn it, it opens, lets water through. And as I mentioned, in this particular case, this is a valve and a filter combination. So this simply has a filter connected to it. There's lots of different types of filter combinations. And if you're using drip irrigation, I would recommend using some sort of a valve filter pressure regulator combination. In this case, here's a filter and a pressure regulator together. Now these are just threaded pieces together. It's not one piece. So this has a little, they call it a Y filter because it's shaped like a Y, just a little filter screen in there. And this is the pressure regulator. Now notice it says 30 PSI. So you can get all kinds of different pressure regulators that have various PSI, pressure pounds per square inch. For drip irrigation, some of them go as low, some of them you may want to go as low as 10. But kind of average, 30, 35 is probably a good PSI for a drip, your average drip system. Again, depending on some factors. But I would recommend that because too high a pressure, you can end up popping off emitters. You can end up having some issues with drip irrigation with too high of pressure. For sprinkler zones, depending on where you live, you may also want to install a pressure regulator because some of you may have pressure as high as 900 PSI coming through your system, coming through the point of connection. And with that, it's at high pressure. Most sprinkler heads and products are designed to operate at a pressure range somewhere down in the 30 to 50 range. And so you get 100 PSI, it's pushing water like crazy through there, and a lot of it turns to mist. It's not distributing the water as it's engineered, so the droplet sizes and everything change. So if you have really, really high pressure, sometimes a pressure regulator can facilitate the management of your system better. So I also wanted to talk about, in the event that you need to add a zone, you've already got a system in, but you want to add an area, you want to do a vegetable garden, you want to do something that's a little bit unique, or add an irrigation system to some pots around around a patio or something like that. They do sell a drip, or not a drip, it's a battery operated valve. So here we've got, this is missing a little stand, but here's the actual controller. It's hooked to your pipe, so you could put this in anywhere. But rather than run a wire, have to worry about running a wire clear back to your timer, well, this is essentially a little timer, in this particular case, to operate four valves. You could actually put 4 valves and operate it with this little battery operated unit. It's a 9-volt battery. You change the battery once a year. This just plugs into the back, just connects here. You could, like I said, it has a little stand that mounts right on top. But that's one method or one alternative. If you've got water, if you've got a live water source, meaning a pressurized water source, a hose spigot somewhere, but you wanted to turn that into a valve, you could easily add a battery operated valve at that location and then do a drip zone onto a vegetable bed, do you know, something, anything you want to do without having to go clear back to the timer. The downside to that is now you're operating multiple timers. You do have to keep checking on this. You'd make the setting adjustments. Not nearly as sophisticated settings or controls, although now with the technology of smart controllers, you're starting to see some hose-in smart controllers, timers, where they link to your phone, just like other smart control. You can buy those, there's rebates for those, but they are controlled then just like other smart controllers. They take weather inputs, you see the app, you can change, you can change things and actually see what's happening from your phone app. So I think with that I've covered valves, and there's a couple of questions I'll address here really quick.
One, how tight should the solenoid be?
Okay, the question was how tight should the solenoid be? So I'm going to grab this just an example. So again, remember this is the solenoid. Generally speaking, the solenoids usually aren't tight. I mean, they're tight enough they're not leaking, because if they're not tight enough, they can leak. There's a little seal, there's a little rubber gasket in there. They need to be tight enough that they seal, but ideally you should be able to turn that by hand. On some older valves, maybe some brass valves, some different things, it could be corroded, or somebody could have got some pliers on there and really tightened that down. In most cases, for most valves, that should be loosened, tight enough that it seals, but loose enough that you can turn it by hand, because in most cases it's the solenoid, something around to open and close manually the operation of that valve. Now some valves have a little switch on the side, and so you're doing manually turning on and off with this little on-off side switch, or you know, sometimes a little dial here. But generally speaking, those shouldn't be so tight that you need to get pliers on them. If it's that tight, I wonder if it was leaking at some point, somebody really just cranked it down with pliers to seal it up. Maybe it just needs a little O-ring gasket or something to help seal that up. All right, so let's move on to sprinkler heads. I'm just going to set them right here. I'll just set a couple behind me here. Okay, so what we're going to do is talk about sprinkler heads for a minute. I always get too excited and get all my hands full, and here I'll just stick some in my pockets and wherever. Okay, so sprinkler heads have evolved from this. This is an old brass impact head. And you used to see these all over in parks. Some parks still use these. They can be really large. They can really shoot out some water. So sprinkler heads have kind of evolved from this, and you still see this in agriculture. This is it's a good sprinkler head. It delivers water, and it can get water long distances and cover large areas. So this brass impact head kind of evolved to the residential impact head, which was this. Now Rainbird this is a Rainbird one, and it's called the Maxi Paw, but other manufacturers have these impact heads as well. Now it's kind of tight, so I can't pull the top out of this for you to see without a screwdriver or something to pry that in. But this little, just like that brass one, impact, it pushes that around back and forth. It makes that traditional sound, and it goes back and forth across your lawn. And these can shoot water. Funny enough, look at this on the side here. This has nozzles. You can actually adjust nozzles in here, and depending on the nozzle you put in there, and how you adjust those, it will determine the throw radius. How far am I actually throwing water with this depends on the adjustments you make. So these can throw water 30, 35 feet. It can be brought back. You can adjust those back, so maybe you only need 20 feet. But for larger areas, you know, needing a bit of distance of throw, these work fine. So the other type of head for large areas are these gear-driven. It's also a Rainbird head, but all the manufacturers make one of these. And again, the springs on these are really tight. I should have had one open. But these pop up just the same. The water pushes this up, and then there's a little gear. There's gears inside there, so this is a silent movement, but it goes back and forth across the lawn. But it shoots water just like the impact head. You can get water 30 feet out, 35 feet out. If you get the bigger ones, there's some commercial ones that'll go 50 feet, 50, 60 feet that they use on parks, and some of that takes a lot of volume, but you can really get water moving on these. Typical residential, you might have a Rainbird 5000 or a Hunt or something, an Orbit something, and you're shooting water 30 feet, 20 feet, 25 feet. And again, these have a nozzle as well. This is really important. I'm gonna talk about some setups here, but while we're talking about heads, I want to emphasize that when you buy a sprinkler head like this, if you buy it from a sprinkler supply place or even Home Depot, most of the time they come either with it wrapped up like this, or the sprinkler supply people nozzle tree. Now this has all kinds of different nozzles. Every sprinkler should have a nozzle tree. Now the reason being is each one of these nozzles has a different number on it. It'll be a 1 point something, a 2 point, 3 point, 4.0, you know, 2.5, whatever. So, and the holes, you probably can't tell from this, the holes on these nozzles are different sizes. So depending on the nozzle that you put in here, that's going to allow more or less water to pass through this head as you're irrigating. Now, really, really important, most of the time, if you have one in the center and it needs to go all the way around, let's say you would start with a 4. And because this is going all the way around, you know how long it takes to go all the way around, but if you have one over next to it that only goes halfway around, in that head, you would put a 2, because it's really only covering half the area of the 4, right? And then if there's a quarter, you would use a 1. That's why they have these nozzles, is so you can match the rate of application of each of the sprinklers based on the area that they have to cover. So it's basically in quarter increments. You have quarter spray, half spray. You could do 3/4 spray or full circle spray. And then there's enough nozzles in here that you can make those simple adjustments so that you get the rate of application of water down. So the one that's making a full circle, it's actually putting a lot more water as it goes, because it has to take a much longer time to go all the way around than that half does when it only goes halfway around. I hope that's clear. Very, very important. If you're using these kind of heads, sometimes I've seen where maybe the nozzle tree didn't come with it, or maybe they're just, somebody didn't know. You're doing that, the corners and the sides and the halves, they're putting down the same amount of water as the center one. And so as this goes around, the corners and the edges are much, much wetter than the big circles in the middle. And then the question is, well, I've got these big brown spots in the middle. So naturally, you turn your sprinkler system up more. When is you should be adjusting nozzles so it decreases the rate on those others compared to the full circle head. So I hope that's a clear understanding of these gear-driven heads. Very useful, very efficient. They deliver water very evenly across an area. Okay, now I'm going to move on to spray irrigation, and then I'm going to come back to something about the uniformity of coverage. So spray heads, these are called pop-up spray. With these, the nozzles simply pop up, and then it sprays a pattern. The nozzle is what dictates the pattern. And most nozzles will say, they'll have little marks on them that'll indicate it's a half circle spray, a quarter circle spray. Some of them, they can be adjusted. There's a little screw adjustment on top. You can adjust it so less water comes through the pipe. They can be adjusted so that it changes the arc. So you can change it from half circle to third circle or quarter circle. Now those are not nearly as efficient. Now also, while I'm talking about pop-ups, they also have, all the manufacturers make them, these little rotary nozzles. So it attaches here. These nozzles can unscrew while we're talking about this. So these can unscrew. There's a little screen in there. Sometimes you want to check those. If you're not getting water out of these, check that. That could be plugged up if you don't have a good filter on your system. And then these other nozzles can simply go right on. Now these rotary nozzles, what they do is they take the spray pattern, instead of popping up and spraying a fixed pattern, these are engineered to rotate. And so it puts out little fingers of spray and they rotate around in a circle. Now what that's doing is it sometimes helps in low pressure situations to switch to these, because the rate of application is much lower. It's cutting the rate in half, and sometimes it's increasing the radius a little bit to cover and to get water more slowly into a landscape. You'd want to do this in heavy clay applications where you don't want water applied very quickly because it can't soak in as fast. So then heavy clay, you could use the rotary nozzles. Slopes, you could use rotary nozzles, or low pressure situations. And there's different kinds, different throw radius. If you've got 10 feet versus 15 feet to 30 feet, you can usually find a nozzle that will cover the distance that you need. So while I was talking about pop-up heads, I wanted to talk about those the rotary nozzles, because it's really important. If you have different difficult challenges, you could use those. Now, what I would strongly recommend right now is don't start mixing fixed spray with rotary nozzles. Again, the rate of application of delivery is so different. One area will be flooded and the other area will be dry if you're running those in the same amount of time. So choose a nozzle and switch all of the heads. All the nozzles on that zone need to be switched if you switch any. Now, occasionally, with a rotor, if you're using the big rotors, if for some reason the system was designed and you have pop-up sprays and rotors together, by switching that nozzle to the little rotary nozzles, it comes much, much closer to the rate of application of these big gear-driven heads. So I would recommend, if you've got fixed spray and rotor on the same zone, switch those nozzles, because the length of time you need to run this zone will better match up with a rotary nozzle. You're running this zone for 40 minutes, 45 minutes, and that would be better for these. Typical pop-up spray run times could be as low as 10 minutes and kind of maybe an average of 15 or 20. But you'd want to just always consider the rate of application. So what I've got here, oh, this is a little gear-driven head, and this probably, yeah, this spring does pop out. Sorry, I didn't realize which one I stuck in my pocket. I get all carried away. So yeah, let me pop this one out. This is a gear-driven, it's a smaller gear-driven head, but I want to point out that there is a nozzle inside this one. It's a green nozzle. Those nozzles can be, there's a place you can stick a screwdriver right up in the top of here, and you can switch those nozzles out. And so anyway, that's enough of that. The springs on those are, as you can hear, you know, that it's a tight little spring on there. So back to spray heads. They come in, you know, here's what they call a 4-inch pop-up. Now the little spring in there it only pops up a little bit. The body of that is 4 inches tall. It's only going to give you about 2 inches above the body of spray. So if there's foliage or something here, that's going to block. Whereas you get something like this guy, this is, I think this is an 8-inch. Well, they call this an 1800. Anyway, it's like an 8-inch pop-up. And you look, that thing, see, that'll pop up well above the base, but you also need to have a deeper trench. You need a deeper setup of how those are hooking on. So, but just so you know, there's a range of products that can meet pretty much all of your needs. Tie in on the side. Some people put a little drain on the bottom of these because, you know, it's about the same height as your 4-inch pop-up on a little riser. So with that, I'm going to switch gears, and there's just a couple more questions.
It's just a suggestion, a reminder to cover head coverage.
Oh, thank you. Yes, I was just about to get to, and there was a question that was just brought up about head-to-head coverage. And I'm going to get to that, but since it was brought up, I'll mention it, and then I'll kind of demonstrate out here with our stuff. Head-to-head coverage means that the spray from one head needs to reach the spray to the next. So here, this head needs to reach this head. They're designed and engineered that way. And so if you have a 10-foot throw radius here, then this sprinkler head needs to be 10 feet away from this head. So spray comes here, it reaches here, this one reaches back. Now, the mistake too many of us make, and you learn over time, is it says 10 feet, so I'll spread my sprinklers 20 feet apart, because 10 plus 10 is 20, right? And that's logical, it just meets in the middle. Well, sprinkler products are not engineered that way. The throw, the water droplet size, everything. So you need to put the spray heads the distance that the nozzle says it'll spray. 10 feet, 15 feet, so forth. Okay, that's called head-to-head coverage, and it's very, very important if you want uniform application of water. Yes, it's going to cost you more because you have to add more sprinkler heads in an area, but you'll have much better results, a more uniform application of water. And anytime we're irrigating, we're really trying to simulate rain. We want uniform application everywhere. You don't want really soggy spots and really dry spots, because that's what ends up being brown and swampy mushrooms or whatever. Okay, so, all right, that's with some sprinkler heads. And I'm gonna talk about, I'll talk about a few more pieces there. I'm gonna just transition for a minute to talk about drip irrigation parts, and then I'm gonna get into the actual, how do you build a system? Like, what are the actual parts of the system? Okay, so let's talk drip irrigation first. And as I mentioned at the beginning, with different pipe types. So with drip irrigation, you're gonna be using a poly pipe. Now, poly pipes come in different sizes and different colors. You might find a little poly pipe that's brown or black. You rarely will you use a 1-inch pipe for drip irrigation. It's just not necessary. The flow rate is so low, and the emitters you're adding, you don't need a 1-inch pipe. So usually you're talking about a 1/2 inch pipe or a 3/4 inch pipe. Thin enough walled that you can punch an emitter into, so I've got, this is a little example. So an emitter can be punched right into the poly, a little barbed fitting punches right in. And let me get one of these to show you what they look like before they're punched in. So here's a little emitter. Sorry, my fingers are gonna get right in the way. Has a little barb, and that barb, of course, then pushes right into the pipe. Or there's a little couplers that punch into the pipe, connecting to a 1/4 inch tubing, and then the emitter connects on the end of that tubing. Now these emitters have a little, what they call a bug cap on them. But generally speaking, that emitter, you know, just looks like that. So the 1/4 inch tubing, sometimes referred to as spaghetti tubing, is simply to deliver water where you need it. And I'm going to talk about the different types of drip irrigation. So that can be done with 1/4 or 1/2 inch tubing as well. An emitter can be punched into 1/2 inch. If you're doing that though, you want to be very careful because this tubing is soft and it squeezes. If you're punching in your emitters, you might have a tendency to punch all the way through both layers. So you'd want to be careful using a 1/2 inch, but it can be done with 1/2 inch just fine. You just need to be careful not to punch your emitter all the way through. Okay, now remember, use the thin-walled pipe. If you use a regular thick-walled poly, there's no way you're punching those little barbs through without a special tool, without drilling a little hole or something. There's just no way to punch those through. It's way too difficult. So drip irrigation components, poly pipe, emitters, rarely do you have any glue involved. You know, it's just low pressure, and so everything can just be pushed together. Here's a tiny little cross section of a pipe with 2 little connections in it out to, this would deliver water to the base of your plant. Now while we're talking about emitters, I want to just emphasize there are different volumes of emitters. Now, wow, I get on my hands full, get so excited about all this stuff. Okay, so a lot of times they're color coded. You can see this one is red, and this is a rainbird emitter. Every manufacturer sells emitters. Some look like this. It's a flag emitter. The one advantage to a flag emitter is usually you can pop that end off, that little flag part, and water will come flushing through. If there's a little bit of debris, sometimes it flushes that out of there. But if those get loose, the downside is they just start popping out on their own, and that's a problem. But emitters then this is what regulates the flow. And these are pressure compensating, meaning that it doesn't matter how many of these you have, all of them will put out the same volume because it dictates how much water flows through it. So in this one, it's a 2 gallon per hour emitter. In this one happens to be a 1 gallon per hour emitter. You can get emitters that are up to 5 gallon per hour emitters. I think they even sell them up to 10. There's a huge range. The most common will be 0.5, 1, or 2 gallon emitters. That's the most common that you see. And that's pretty typical. That's kind of a good average size for residential landscapes. You put a 1 gallon per hour emitter at the base of a perennial. You know that every time you water, if you run it for an hour, that plant gets 1 gallon of water. And that's a pretty good gauge. Most of the time you're designing your systems, your drip systems, to run for that, whatever the duration is per hour, the emitter duration. You're running it for an hour because you know you'll get 2 gallons on that plant, or 1 gallon. Now, one thing to be considerate of is if you're using secondary water, you would need your main filter, but you need a supplemental filter on your system to be able to filter down so you don't get debris plugging these emitters. And I'll talk about filter size. No, let me just talk about it. I'll talk about it in just a second. Let me finish the size that you'd need for the main line versus the other. I'll actually talk about it when I get to the system here. So I hope there's not any questions about emitters. Emitters are actually to direct water specific to very specific locations in your garden, in your landscape, to specific trees, specific shrubs, and you're controlling the volume of each of those. So there's one question before we move on to inline emitters.
The question is, can you put different emitters on a single line?
The question was, can you put different emitters on a single drip line? And the answer is yes, because the emitter controls volume. If you have a plant that you know needs more water, more volume, then put a 2 or 3, or you can actually apply 4 emitters to that one plant and only 1 emitter over here to this other plant. The one challenge you're going to have is frequency. You still are operating these at the same frequency. You're just delivering a different amount of water at different locations in your landscape. But that is a perfect application for drip emitters. When you know this area over here doesn't need quite as much, and this area does, so you change the emitter volume on those different areas. Now you're regulating where you need a little more versus a little less, and you don't flood or dry something out. So definitely you can mix emitters on the same line. It's a great application for that. Now, any other questions on that? Okay, so we're good. Okay, now let me talk about inline emitters quickly. There's a tubing. Now, every manufacturer has all these products. That's the thing. Sometimes what happens, though, is we get accustomed to calling something by its brand name, like Band-Aid. You know, well, it's a brand name. But we do that with irrigation parts all the time. You often hear, oh, I have Rainbirds. Well, whether it's that brand or not, it's just become something we say. So a lot of times this product is referred to as Netafim. Netafim is a brand, but it's inline drip tubing. And it's usually brown. It can range in colors. There's a black one as well. And it has the emitter built inside the pipe. Now, the advantages and disadvantages. Now, I'll try to zoom right in on this thing. This is a cross section I've cut into the pipe at the emitter. You know, here's a little bulge. You can see that's where the emitter is located and a little hole. So I've cut into that. Inside here, there's just a little mechanism there that controls the volume, controls the flow. Rather than an emitter punched in, it's already inside the pipe. Now these you can't change. So it is going to be whatever you buy, 0.9 gallons per minute, 0.6 gallons per minute. You know, whatever you buy, that's what it is across the board. Spacing also is what you buy. You can buy it at 12-inch spacing, 18-inch spacing, 24-inch spacing, and so on. Now, how you would use this, I'm going to step back a little bit so maybe you can see this whole thing. You got it? You can see the whole thing. The way you would use this is it needs to be set up in a grid. Now, this is a very small scale for this, okay? I just wanted to do this to illustrate the point. Water coming in, you have basically a header line, a footer line, this is what we call it, and then it's all circulating. So it's all connected together. And then sometimes at the very end, somewhere over here, you actually have a little blow off. So its pressure is released, it allows water out. But anyway, it's basically allowing water to circulate evenly throughout all these lines. And the application of this is on the ground. It's watering everything uniformly because there's emitters spaced all throughout the area. So this application for this would be for very heavily planted areas. You don't want drip tubing scattered everywhere, the little spaghetti tubing. You can bury this just slightly below the ground or hide it under mulch. And then this will water a heavily, densely planted area evenly because it's putting water down in this almost this square grid-like pattern. And as water goes down, it also moves out. And so you're soaking that entire bed without overspraying or getting the spray blocked in the case of a shrub, a taller plant, or anything like that. The other application for this is if you had just a row of trees, a row of something. You could take this, now I don't have a longer piece, but you could take this pipe and you could just simply run it down the row, and at the tree, you could make a couple of loops around the base of the tree, not right at the trunk. You go out a little bit, depending on the size of the tree and the drip line of the tree, you could make a couple of loops and then carry on down, make a couple more loops at the next tree, and so on and so on. That way you're getting multiple emitters around a tree, and then you'll have a few in between, but then you're able to water a row of trees very effectively with drip irrigation without having to do spaghetti tubing and multiple emitters. This can be an effective way to do that. So couple things then. This method, this is called point source drip because you're directing water to a specific point, okay, with the emitter. This inline drip, it's not specific to a point, but you can direct water. You're still in charge of directing where it goes, and it's flexible enough. It can move through curved beds. You know, you have a lot of control, but those are the two types of, the two main types of drip irrigation, okay? Now, while we're on that, I wanted to mention, for those that do vegetable gardens, I'm not going to spend a lot of time with this, but one other method for a raised bed for a vegetable garden is you could use what's called drip tape, sometimes referred to as trickle tape. Now, here's a setup, same poly line, 3/4 inch poly line. It has these little connectors. If I can, super easy to undo and put together, you know, it unscrews. So this is really thin, if I can even get it off. It's really thin, flat tubing. It's meant to be in a row, okay? So it's really thin. This stuff is operated at low pressure. You know, you're basically operating this at 10 to 12 PSI. That little fitting punches in, and then that just fits over the top, screws together. There's another fitting like that for the end, or you can fold up the end and slip a little piece over it. That will leak. These usually don't leak. But the idea is that sits flat. It's got special little channels in it, and it has not an emitter, but a little output every so often, depending on what you buy. 6-inch spacing, 4-inch spacing, 12-inch spacing. And as you run that down a row, it's pressure regulating, pressure compensating, so that each of those little outputs puts down the same volume of water. So I've actually used this on my vegetable garden for years. And if you have a row of 30 feet, this will water that entire row very evenly, very effectively and efficiently. It doesn't waste a lot of water. It's low pressure and low volume, so it runs for a long time. The output on this is similar to some of the others, about 1 gallon per hour type of a flow. So when I use this on a vegetable garden, I'll run it for about an hour. You know, sometimes depending midsummer, if it's not quite enough, it dries out quickly, you'd run it for 70 minutes. But that evenly waters the row. If you do a row of corn, peas, you know, whatever it is, even tomatoes, sure, there's a little space between each of these. You have a little bit of water between them, but that works very effectively, even on a raised bed. Even if you only have short rows of 10 feet, it can work very effectively. It's not really sold that I know of anywhere locally. You buy it online. If you're interested in that, just do some searching for drip tape or trickle tape. Lots of manufacturers, lots of vendors online. I bought it from a company called DripWorks before. There's Sprinkler Supply Warehouse. There's a lot of different online sources for this and the fittings. If you're doing this in rows, you have your header line that basically runs along one side. All of these can go down a row. So you got 2 or 3 or 10. Depending on the size of your garden, you might have 2 zones. I'm able to run 20 of these lines on one zone just fine for my vegetable garden. About rows of about 30, 35 feet long. So it works really well. So I'm not going to spend any more time on trickle tape for vegetable gardens. I'm going to move on to some other things. I'll put this over here. All right, while we're talking about, actually, yeah, no, this is a good time. While we're talking about drip irrigation, let me talk about just a few mechanisms or a few ways in which you can either doing it from the beginning or retrofitting a sprinkler head. Okay, so here's a product. Let me grab Sorry, I have to pause for a second here. So, you know, a lot of times using PVC and risers, you know, there's a typical riser and then a sprinkler head on top of that riser. We'll use this as an example. So there's a sprinkler head. Okay, now that's going to be deep in the ground. This is probably way too tall to illustrate that, but kind of the concept. You got a riser, you got a sprinkler head. Now, if you were retrofitting, there are products like this. This is only one. Here's a different type of product that essentially you can change out a drip or spray head and then put the riser on top, and now you have a drip converter. And then depending on how you do that, you may need to reduce pressure back at the valve, or in many of the cases, there's a pressure regulator built into these. So it reduces the pressure down. On top of these, then you're able to put the tubing, and this same type of tubing would plug into these. This would allow eight different tubes to be on top of that. This one allows 8 as well. Inside of here, I mentioned there's a pressure regulator, there's a tiny little filter screen, and then you can put emitters right here, or you can put an emitter out at the end. I like to actually have the emitter on the end. Then I know what's happening. I can see that it's working, that it's plugged or not, and so forth. So, but anyway, that's one way. Another way to make a conversion. So if you're converting from a spray head to a drip, there is this kind of product. So again, imagine here's your normal spray head. It's got the normal top on it. Actually, while I'm doing this, I'll just grab one of these and show you. Okay, so here's your spray head. It's got the normal nozzle on it, normal everything. So what you can do, instead of digging everything up, if you wanted to change a whole zone, a park strip is a perfect example for this, or you're taking things out, you're trying to rearrange, and you need to convert the spray heads to drip. Without digging anything up, you can just dig around the head a little bit so you don't get a lot of dirt in there. You can unscrew this whole top. Now inside there, it's gonna look like this. It's this whole spring. There's nothing else in there. That's all there is. So you can just pull that out, and then there's this product. It actually comes as a whole thing like this, but if you already had the spray body, those are exactly the same size. You pull the guts out of one, you have this device here. It already has a filter screen. Inside here is a pressure regulator. You slide that in the ground, screw it back together. Now you have the ability to connect drip tubing to that and run emitters where you need. Or if you needed, there's a little, since this is a threaded fitting right here, if you don't want to do spaghetti tubing, they have little threaded adapters where this one happens to be straight, but you can buy 90 degree. You can screw that on, and now this is a barb fitting to your 1/2 inch. This is the barb fitting to the 1/2 inch drip, inline drip. Or there's the same fitting for a 3/4 inch poly pipe that now takes and runs it wherever you need to run it. Okay, so that's a simple way to convert from spray to drip without digging up the entire line, trying to cap everything. However, when you do this, you'd either need to do this with each head. Let's see, oh, there it is. You need to do this with each head and put a part on it. Or you do need to do something about capping those heads. That's where you probably would have to dig up a few heads and just put a plug in the line where that comes from, off the riser, off the swing joint, or whatever you have. So that's a really important thing, because you don't want to mix spray and drip. Again, you're not going to succeed trying to do spray with one and drip with one, because you're going to run, if you run your spray system for an hour, you're going to have a flood, and this is barely getting what it needs. So always keep that in mind. So I hope there's a couple questions, I guess, or at least one that we can cover related to this.
How often do you need to replace the tube for drip?
The question was, how often might you need to replace the drip tubing? So that's a great question. This spaghetti tubing, if it's sitting out in the sun is the enemy for this tubing. If it sits out in the sun over the course of a few years, it can just get brittle. And as it gets brittle, if it moves, it cracks, and then you'll need to replace that. If the drip tubing is underground or under mulch and it's out of the sun, it will last for years. And there would be no reason to have to replace it for anything unless it somehow gets plugged up. But the sun is going to be your enemy. So if you keep those from being exposed to sunlight, they can last for years. There's no reason to be replacing them. All right, so, all right, I think we're going to move on. Really, really quickly though, I forgot to mention, I get ahead of myself. I forgot to mention a couple tools. You can buy, in the event you're using PVC, you can buy a cool little cutter like this, and it ratchets down. So as you can, I'm not going to cut this piece, but it goes right over, and you can use your own hands to ratchet down, and that blade will just simply cut through a piece of pipe super easy. Okay, it'll cut through 1-inch pipe on this type of size, and you can do that. The other method for cutting PVC is you have to the saw. I guess if you're doing brand new stuff and you don't have repairs, you could use a power saw to cut through those. I've seen guys with reciprocating saws in the field. You know, it's basically a hacksaw blade on a reciprocating saw to cut through those. So, but if you don't have a power tool for that, that's a great way to do it. If you're using poly, they have this special little cutter. You know, it fits right around, and then you can easily just slice right through poly. I mean, I can cut a little bit of, that piece just went flying. So, super easy tools to work with, super easy to cut, super easy to put stuff together. Drip irrigation is really, it takes sometimes a little more time to set up because you're pushing barbs together and you're directing tubing. But once it's set up, it operates really effectively, really efficiently. The key is filtration. And I'm gonna get to the filtration part right now. All right, so I think I've talked about almost everything. There's one more thing I should show you. In the event that you're just trying to operate things from the drip irrigation from a hose, they do have fittings. This is actually a pressure regulator that would thread onto a hose threading. Now, hose threading and pipe threading are different. They're just a different type of thread. So you'd need an adapter piece that goes from hose to regular standard pipe thread. And in this case, this one would go from the hose spigot. It threads on the pipe thread to a pressure regulator backwards. So, and these regulators always tell you the direction of flow. There's a little arrow there. And so this one says 25 PSI, and it tells you a flow rate, 8 gallons per minute flow. But you could set that up. You could then connect fittings, connect poly line, and right from a hose spigot, again, you can add a battery operated valve if that's what you need to do. There are lots of pieces available. You don't find a lot of these pieces maybe at Home Depot or Lowe's. You might have to do a little looking at sprinkler supply stores or online. All right. Okay, with that, I think it's time to start moving into the actual system part of it. I think I've covered the basics of parts: pipe, valves, sprinkler heads, drip irrigation parts. Now I just want to talk about the layout. Actually, I'm going to do one more about the layout. I'll demonstrate it, but then I'll show you. Okay, so the layout of this is going to take us probably just another 15 to 20 minutes, and you'll be an expert and you'll know what's going on in your system. One last thing. Here's a setup, what we call a swing joint. So if you're using PVC, that's connected. You've got a little fitting on the back side here. This is a 1/2 inch thicker walled poly. Sometimes they refer to that as funny pipe. And then it has a fitting up here that they call the swing joint. Now what this does, this allows the pipe to be at whatever depth, or even the fitting. It can be upright, it can be sideways. It doesn't even matter where that is. If it's crooked, if you're using risers and rigid pipe, it's very important that those are perfectly straight and all this kind of stuff, or you get your heads tilted. If something drives over that, it can crack the fitting. So this swing joint has all kinds of advantages. Number one, you can make sure the head is tilted straight. It doesn't even matter. If your pipe is a foot down, you can easily adapt the level of your sprinkler head so that it's at proper grade, right? Or if your pipe is a little shallow, you can still get that sprinkler head at proper grade. If it needs to be away from a sidewalk or something, The funny pipe allows you to move it. Now this length right here is not specific. You make that length whatever you want. Sometimes if you need to move ahead, this is the ideal way to do it. Because if you need to move ahead just 2 feet, well, get down to that fitting, make a new connection, and then realign everything so that give yourself another 2 feet and move that head over 2 feet. You wouldn't want to go 2 feet or more, but for 3 to 4 feet or so like that, it would be super easy. You can move ahead. It becomes very effective for getting the head placement where you need it. Okay, so with that, I'm going to now, Janice, you'll probably have to turn the camera a little bit. So I'm going to start talking about the setup of how you do this. Okay, I'm going to start at the street. Now, some of you are going to be in the backyard. Your point of connection of service for secondary water or something may come into the backyard and that way. For this demonstration, just flip it all around. But for sake of what we're talking about here, I'm pretending we're at the street. So this over here is road. You have a point of connection. Usually the utility has their point of connection in some sort of enclosure. So Weaver Basin, for example, we have a valve cover. It's in a purple lid. If you have a secondary meter, it's in a purple lid. There's a meter there with a valve that is the district's service valve. Then that usually comes, that's in the park strip area out there, you know, right next to the curb most of the time. As that comes in, then usually you should have, here's your sidewalk, usually you should have a green box. And that green box would be covering your valve. And your valve sometimes would look like this. It would be simply a brass valve that can be, now your valve may not look exactly like this, but your valve can be open or closed. So this is closed, this is open, and then a filter. Now, a lot of times these are right close together and they're in one green box. You may not have a filter, or your filter may actually be clear up by your valves. But this is kind of a typical scenario that many, many sprinkler systems have. First, user valve, or excuse me, service valve in the street, by the street, sidewalk, then your valve and filter together. And I skip filters. I'll come back to filters because I want to finish. I get sidetracked. I'll come back to the filter in just a second. Now then, this is called your main line, and the main line takes water and is always pressurized to what we call a valve assembly. Now your valve assembly will also be typically box. So if you'll imagine with me, your main line comes in to the green valve box. Inside the green valve box, though, you would have your valves. So in this case, there's 3 valves right here. In your valve box, you may have 2, you may have 3, you may have 4. Depending on how it's built, you could even have 5. They do sell different size boxes as well. Now, in this case, some people will build their own valve assemblies with PVC. So you can have little PVC fittings all glued together. It's just fine. These actually have these cool little unions, so that if you ever needed to take this valve out, you know, it's simple. Well, simple unless you're demonstrating. It's simple to take that out, and then you can unscrew these. Usually you have them on both sides, so it's real easy to take that valve out if that valve ever needs to be replaced. Okay, and then you can slip a new one in, tighten all the fittings back together. If everything is glued and something happens to that valve, you're going to have kind of a mess cutting the entire thing apart to try to get your valve fixed. Okay, and so it helps to have these pre-made manifolds with those valve unions that make it easy to take apart. Now, while we're at the valves, I'm going to talk about wiring. Now, if you've got time clocks, we're just going to imagine your time clock is back at the garage or the shed or wherever. So there's sprinkler wire, and your sprinkler wire typically has, you can buy a sprinkler wire with, this one has 5 wires, but it's actually only meant for 4 zones. There's always one white one that's going to be called common, and each of these would be for 1 valve each. So if you need an extension, you can buy more wire. And then this wire, you can run it 50 feet, 100 feet, whatever the case may be. And sometimes this wire is running right next to the mainline pipe, taking it back to a hose spigot, taking it back to a shed. Sometimes it's just directly buried, and you could chop through that with a shovel. And then you have problems because none of your valves work. So the idea here is that when you're connecting a valve, as I mentioned before, there are 2 wires on a valve. Let's see, I'll use this one because they're longer. There are 2 wires on a valve. One of those wires is going to go to white, and then one of them will go to one of the other colors. The other one over here, one of those will go to white, and the other one will go to red, and then the other one will go to yellow. So each one of these gets one color, each one of these connects to white. So the white wire is actually connected to all 3 valves, and then each of these, it gets 1 wire. Now when you go back to the valve, back to your clock, you would know, oh, the green is connected to that valve goes to the front yard. Okay, my green station number 1 is front yard. My red station number 2 is side yard. My yellow station number 3 is, you know, whatever, the flower bed. Okay, so that's how that works, being wired back to the clock. Each valve gets a wire, each is connected to white. Okay, so that's kind of the main setup. Now let's talk about what's referred to as lateral lines. So Janice is going to kind of show this. I think I'll start out here, but knowing a line comes from the valve, and this, I've got it color coded in red here. So red is our front yard, okay? Now notice I've got 6 sprinkler heads in the front yard. And how it's set up, I kind of got it. So you don't typically want to set up crazy configurations of pipe, because water and hydraulics, it does have to move. There's some friction loss. Ideally, you have kind of a line with it teeing off in different directions rather than trying to make big circular patterns of pipe. So this one has six heads. Ideally, each of these has a swing joint so that I can put that head exactly where I need it. I can keep it level, straight, at grade. And then ideally, your spacing is, for head-to-head coverage, you've got spray from this one reaching this one. Now this is a small scale model, but assuming this was your front yard and you needed 10 sprinkler heads for the yard, then you would decide, do I have enough flow volume for 10 heads, like we talked about before? If not, you would need 2 separate lateral lines, 2 separate valves, and one sprinkler heads, 5 or 6, and the other would do 5 or 6, if you need 10 to 12 heads. Ideally, I would say probably never go above 8 or 9. You'll probably run into problems if you go above 8 or 9. If you're in that range of 8 sprinkler heads and that's all you need, you probably could get away with it with one zone, but I'd have somebody either test your pressure, test your flow, make sure you have the flow volume to feed that many. But a lot of times 8 is about right. On the big gear-driven heads, sometimes you probably want to go no more than 4 or 5. You may get away with 6. So there's the layout of one zone, your front yard. Okay, head-to-head coverage. If we covered this all with dirt and just stuck flags where the heads were, you'd just see 6 flags, right? And ideally, the spacing of those would cover the area. Now, most yards are not just a simple little rectangle. So these might be slightly off a little bit, but ideally, when you're planning or doing the sprinkler heads, you want to move and you want to put things so that you're still getting the head-to-head coverage as best as possible. Now, of course, it's not rocket science. You don't have to have every inch perfectly covered. You don't need to over-engineer this thing. But just try to get as close as possible while keeping the heads where you need them to get the whole area covered. Okay? So now I'm going to have Janice pan over this way. So our zone 2 in blue color code here represents a backyard. And in this case, I've got the rotor. We've got rotor heads. Same principles apply. But in this one, notice I only have 4. I'm just assuming pretend this is a large scale, and we're going to be spraying about 30 feet with these each. It's covering a big backyard. So you've set it up just the same principle. Head-to-head coverage. Swing joints make it, again, super easy to make sure the head gets where it needs to be. And as I mentioned, if I need to move one of these heads, I can simply, there's no glue on any of this right here. You can take a knife and carefully cut that, extend the length of that. Let's say I need to move this head 3 feet this way. Well, I can actually dig my trench a little bit this way, extend my length, and now I can put that head clear over here. Or, as we've talked about in localscapes, sometimes you're eliminating grass, you're shrinking your grass space. So without all the, if you just need to move your head 2 or 3 feet in, go back to this point. Again, you're digging only that small piece, relocating this head in. The grass on top of this pipe could be dead, turned into drip or turned into drip or flower beds. And now you've moved that head 3 or 4 feet in simply by using that funny pipe. Again, don't go too long with that. I wouldn't recommend going, probably longer than 8 feet. You just start running into, because look, it shrinks the size of the pipe, it shrinks the water volume delivery. So the longer you go with that, flow through the friction, there's just hydraulics with it. So probably stay less than the 8 feet on the swing joint. If you need to go more than that, dig the trench, realign your actual lap, and you'll be better off. All right, so coming back to our valve assembly. So I've got one drip zone here. Okay, it's got a valve, it's got a filter, and then this happens to be brass fitting. You don't need brass, it's just what we had. It's connected on, and then notice the clamp, and then my poly line. This is a thin-walled poly. It's pretty flexible, it's pretty easy. So in the case of drip, I'm just assuming for my simulated model here that this is going to our flower bed. It's going to the backyard flowers. Okay, it's got the filter, regulator, all built in one, and now I've got drip emitters punched in. So this can easily, because this is, you can take this anywhere. You can snake it, your bed goes clear over here, so you can wind your poly pipe anywhere you need it because it's flexible. Be careful not to go too tight because you can kink this pipe, and anytime it kinks, then it wants to kink there again even more. But at the end, all you simply need to do is put a little plug in it, put a clamp on the end. That's all you need to do for the end. And then if you decide to extend that later, you can undo that clamp, take the plug out, put a different coupler in there, clamp it back together, and you can extend that line if you change your mind in the future and wanted to extend the drip zone further. So I think there was one more zone I didn't talk about much with this little model, and it was our park strip zone. So in this case, assume this is on the other side of the sidewalk. So the sidewalk is running here. Notice I've just got one line. I've got the 3 sprinkler heads on it. And in this case, sprinkler heads in a park strip are really difficult because it's narrow. You've got 5 feet of space, 4 feet sometimes. Unless you've got an 8-foot space, it's just super difficult to water effectively. You got water in the road, water on the sidewalk. So ideally, this is the area that you could easily make those conversions to drip irrigation. So back to the conversion kit that I had here. If you wanted to change these out, super easy. Like I said, you go out to get in your sidewalk. Oops, I chose the wrong. Anyway, you can simply switch this, dig that up, switch it out, whatever, convert this to drip. You can convert the whole park strip to drip if you need. And it's super easy. You can get rid of the grass. I've always kind of had the opinion that the only time you really need grass in your park strip is if you live on a parade route. And then people want to sit there and watch the parade once a year. But if you don't live on a parade route, when do your kids play on that grass? When do you use that grass? Besides the neighborhood dogs maybe that use that grass, when is it used? But you're spending a lot of time trying to keep it green. A lot of water's going down the gutter, lots going on the sidewalk. It's usually poor soils. There's salt issues sometimes with how the roads get plowed. So park strips are just a great area to convert, change it to drip irrigation, change to do something else. So I think I've covered the general overview. I'm gonna have Janice go back to the computer so she can see some questions. And then I think we'll take some questions because we're probably at an hour and a half-ish, an hour and 15. So I think there are some questions. I want to go through some questions and we'll kind of wrap up at this point. This has been just a basic overview, but I do want to make sure if there's questions, let's cover them.
How do you know when your water needs to be filtered?
Oh, filtration. Thank you for that question. Somebody asked, how do you know when your water needs to be filtered? I keep skipping it, and now I'm going to come back to it. Okay, if you have secondary water, just period, if you have secondary water, you should have a filter. Now, a filter like this is a good one for your basic mainline filter. It doesn't have to be this brand. It doesn't have to be clear, you know, canister. They sell lots of different kinds of filters. The key with filtering is you need to know the mesh. This particular filter says 32 mesh. What that means, that's the screen size. Now these filters are nice because it's a stainless steel screen. It's not going to rust. And so water's coming in. It's actually going in this canister and then through the filter down into the pipe. So your junk and debris collects in here. You can see in there if it's gunked up. That's why these are nice. But for a main system, you probably only need something 32 or 50. Now the higher you go on the number, the finer the screen. Okay, so for main sprinkler, just mainline something coming in, 32 or 50 will get out all the large debris. Some of that small debris you can let go through, because if it's just spray heads, that small debris will go through the spray heads just fine. You don't have to worry about it. It won't get plugged up in your heads. Through a 32, or won't go, yeah, excuse me, anything that will go through it usually goes through heads, but if it gets plugged here, it will certainly plug your sprinkler head. So definitely if you're using secondary water, have a filter. Now with drip irrigation, you would want to increase the filtration level. So like with these type of little canister filters, like I talked about with the valves and the little Y filter, I'll pull out one of those. These filters are much finer. So that filter is probably a 100 or a 150. And that's kind of for an average drip irrigation. A 150 is probably a good number. I've seen filters for drip irrigation as high as 400. 400 is really fine. And if you don't do a lot of other filtering, that 400 filter is going to plug up probably daily, well, every day you water, it'll plug. So then you'll have to clean it before you water the next time. If you're filtering drip irrigation at about a 150 level, you probably don't need to go higher than 200 if you're worried about it. You know, but that level right there, it's a fine screen, probably about a 150 to 200. It actually says on it. No, it doesn't say on it. But when you buy them, they will. They'll say what they are on there, as far as the screen size. But always filter your drip irrigation. If you don't, what will end up happening is that tiny little emitter, that emitter gets plugged, or the inline emitter gets plugged, and then your plant starts looking really wilted. It starts to reach what they call the permanent wilting point, and at that point, it's too late. It doesn't recover, and you lose a plant all because your emitter was clogged up. So ideally, filter 400, not 400, 150 to 200 on drip. Mainline 32 to 50 in that range is adequate. So I hope that covered the filtration question.
Do they make self-draining valves for sprinkler lines for winterization?
Okay, the question was, do they make self-draining valves for sprinkler lines? There are drains that are pressure regulating drains, I should say. As long as there's pressure on it, it stays closed. When the pressure is off, water drains. And usually those are installed with a little bit of gravel or something. They do sell those kind of drains. Sometimes people put those directly in their spray, directly below sprinklers. So like in this case, their line might be coming here and they'll put a drain right at the bottom of this sprinkler. When water in the winter, it just naturally will drain out. For a valve assembly, there is not a self-draining drain. If you are worried about freezing or you've had historical problems with freezing, you probably just need to have somebody come and use a little bit. It doesn't have to be real high air pressure, but you use a little air pressure and it blows all the water out the lines. Just a little bit of water in there is not a problem. The problem is in low spots where water remains filling the pipe, or at the valve assembly, if water is full and it doesn't have room to expand, it expands and it cracks the plastic. So as long as you've got room, a little bit of water in there is not going to be a problem if it's got room to expand and contract as it freezes. The power of water as it freezes is incredible. I mean, if you've ever been to southern Utah on the cliffs, the freezing water breaks, millions of pounds of rock off of those sheer faces just because the water is freezing and expanding. So it will break the plastic. The idea is you've got to get it out somehow. So if you're on a little bit of a slope and you leave your main valve open, a lot of times water will siphon. As the main system's drained, water kind of siphons back out and it clears the line. If you're in a little bit of a lower area, it's worth it to either figure out how to get a little air pressure through it yourself or pay somebody to come and just blow that sprinkler line out in the fall. And you don't have to worry about broken lines. Inevitably, we'll have winters that are warmer or cooler, but inevitably at one point or another, if you've got a pipe with water in it that's full, it will break that line.
If you need to install your drip system but don't know exactly where your perennials are going to go in the configuration of the bed, what is the best drip system to install?
Okay, the question was if you're going to install drip irrigation but you don't know the exact configuration of your plantings at this point, what's the best way to go? I would say if you know it's going to be heavily planted, very dense, go with that inline emitter and put it into a grid. And you can plant anywhere in that. Once you decide to plant, you put plants anywhere you want in there. And all you're going to do is watering the empty space between, watering the weeds. So if you know that it's going to be fairly sparse, then use the inline emitter type system. Put in a poly pipe. Poly pipe can be snaked around wherever you want through the bed. And then as you add plants, you can add an extra emitter. And I would do that if you know it's not going to be heavily planted, or if it's going to take you a couple years to fill it, where you're just adding 2 or 3 plants at a time, you can easily add those 2 or 3 emitters as you add plants. Get them covered, bury them just slightly in the soil, put some mulch over them. That would be my recommendation, is just based on how you're planting, how fast it's going to be planted, and how dense. But it's super easy to add emitters. And I should mention, if in the event you use the inline, you could punch in an extra emitter here and there, and you could actually add a little spaghetti tubing if needed. Usually you don't need it, but if you use this and you had a location that just doesn't seem to be getting enough, you could simply add an emitter to that location.
How much water per hour for perennials on drip system, or where can I find this info, if it's there?
Okay, the question was how much water per hour on perennials for drip irrigation. For our garden here, we've got zones that have different things. We have a few zones with 2 gallon per hour emitters, but they actually run less time. And we have some zones with 1 gallon per hour emitters, and they run for about an hour. And we change the frequency depending on the season. So in the spring, it'll run for an hour once a week, or once every 8 days or 10 days, depending on the weather. As summer comes along, we'll be running that maybe twice a week, an hour. So it is going to vary. Most perennials, it depends on the perennial as well. There are some higher water need perennials. But if you're choosing those, I would encourage you to group all those together and create a zone for those so you can water them effectively. Or, as we talked about before, if you have a cooler area on the north side of a house versus a warmer area that's sliding around on the west or something, and those have to be on the same zone, we'll just put a higher volume emitter on those that need more water and try to just be very careful with the frequency, because the ones on the north side won't dry out, and then you'll start to get too much. So put maybe a ½ gallon emitter on the north, 2 gallon emitter on the west, or something to try to balance that water need. I hope that answered that question.
The next one is pretty specific to someone's specific yard.
Okay.
But she wants to know, what is the best way to make one zone into drip when part of it is set up with low flow spray fittings? The 3/4 inch pipe is vertical above ground. You have to change the fitting to something else in order to do a drip on the shrub. It's currently an adjustable spray pattern nozzle, and I need to change it to a drip.
Okay, we had a question that was a little bit specific to an individual's yard about converting from a spray system to a drip. So I'm going to have Janice type back, and I'll try to address your question maybe through an email or a phone call, this one's a little bit specific to your individual yard. It's set up for spray. you want to convert to drip and you have some very specifics there, I'll have Janice send you my emails. You send me an email with your phone number and I'll get back in touch with you, or I'll send you some email on that. Because you start getting into some specifics, it's a little difficult in setting to address those. Let's kind of stick with some general questions, but I'm happy, I want to help you, so shoot me an email if there's some very yard specific, maybe some detailed things, and I can work through those with you on your own.
That's it. That's all we've got.
Okay, I think Janice says that's all the questions. So again, I hope this has given you a basic overview of irrigation, a basic overview of the component parts, how they fit together, the different options that are available to you. There really are thousands and thousands of parts. You can do anything with irrigation to direct the flow. The key to irrigation is you're in charge of directing flow in volume and frequency. And if you can figure out those parts, how much water does it take and how frequently, you've mastered irrigation. You then direct water to the plant when it needs it, instead of just thinking, well, I don't know if it needs it, but I'm going to deliver water anyway. And that's what we're trying to educate people on with lawns all the time, is know how long it takes to fill the reservoir, and then how frequently does it dry out. And that's going to change through the season. Of course, we have this peak in July and August, and then back down. Especially, learn how long it takes to fill your reservoir by about a ½ an inch each time, and then alter the frequency is all you need to do. Once you figure that fill time, never change that time. If it takes you 20 minutes, 20 minutes the same, and then just start adjusting for how often that 20 minutes needs to happen. Now, really quickly, if you're looking at technology and you like technology, there are smart controllers available. You can get rebates for those. Through the Utah Water Savers. We're connected. There's a link from our website to Utah Water Savers, or you can go there directly. Smart controllers, if left in smart mode, if controlled that way, take those weather factors. Once you put in the parameters and the settings, it takes those factors and then it adjusts frequency for you. So if it's cooler and wetter, of course, it's going to let the irrigation happen less frequently. As it gets warmer, it's going to apply water more frequently. So anyway, that's an option for you. If there's further questions, again, get back with us. We would encourage you to watch our website, watch our social media stuff for more information. The next class we've got next week is succulents. That's going to be a good one. And we've got some coming up for June. So look at our June schedule as well. Thanks for joining us today. We're glad you were able to do this, and pay attention to your irrigation. You'll be successful. You'll have great looking landscapes, healthy landscapes, and you'll deliver water more effectively, which is what we're trying to help you with here. So great. Have a good afternoon. Thanks.